Hi there! For this video, we'll be talking about dividing polynomials through the long division method. So let's write that one down. Long division. Now, to discuss this one, let's start by giving an example. Let's have x squared plus 5x plus 6 divided by x plus 3. Now the first step in this one is to arrange the terms of both divisor. Just to recall, if we have this one, this represents the dividend, this represents the divisor, and definitely this is the quotient. So what we should do first is arrange the terms of both divisor and dividend in descending powers. In this case, it's already properly arranged since, as we can observe, the powers of x out here is already descending since we have 2 here, 1 here, then x raised to 0 here, or 1. Oops. Same for the divisor. It is already arranged since this one is x raised to 1 and this one is x raised to 0. So we proceed to the next step. That is, we first write this one as x plus 3, and out here we put in the dividend, which is x squared plus 5x plus 6. Now the next step here is to divide the first term of the dividend by the first term of the divisor. So in here, the first term is this terms out here. So we have x squared over x is simply x. And so we will have this result as the first term of the quotient. And now, just like in multiplication of real numbers, or in long division of real numbers, what we do is we multiply this first term of the quotient into the divisor. So multiplying this one, that will give us x times x plus 3, which is equal to x squared plus 3x. Now from here, this product is the one that we will subtract to the dividend. So we'll have right out here minus x squared plus 3x. Note that in subtracting polynomials, what we do is we distribute this operation out here. So we will have x squared minus x squared out here will simply cancel out. So this will simply be 0 plus 5x minus 3x will give us 2x. After that, we bring down this one out here. So we'll have plus 6 out here. So let's just clear out some space. Let's move this one. Now, if the degree out here is still not 0 or still not less than to our divisor, we continue the process. So again, on this point already, we divide 5x to the first term of this one, which is x, and that will give us, oops, not here but rather here, since this is already the first term. So we'll have 2x over x, simply 2. So we'll have plus 2 out here, multiply this 2, and the product will be subtracted in here. So their product is 2x plus 6. Subtracting this one, we'll have 2x minus 2x will give us 0, and 6 minus 6 will give us 0. And so the answer is already x plus 2. This is the quotient. And the remainder is 0. So that is how we do long division. Now let's try out some examples. Let's have 2y raised to 4 minus 7y cubed plus 17y squared minus 20y plus 16 all over y squared minus 2y plus 3. So I just have written this one differently, but similar idea apply. This will represent the dividend. This will represent the divisor. So writing this out in the long division form, we will have y squared minus 2y plus 3 divided by, let's copy this one, oops, now let's just write it down, 2y raised to 4 minus 7y cubed plus 17y squared minus 20y plus 16. Now let's minimize this one to save some space. Let's put it out here. And so with this one, let's do the similar process a while ago. First, we divide this one by this term. That will give us 2y squared. Multiply this one to this one, and that product will be subtracted in here. So we'll have 2y squared times y squared is 2y raised to 4. 2y squared times negative 2y will give us negative 4y cubed. And 2y squared times 3 will give us plus 6y squared. Subtracting, this one will give us 0. Negative 7y cubed minus negative 4y cubed will give us, will be like this, 7y cubed minus 4y cubed minus negative 4. So we'll distribute the negative sign, will give us 17y cubed plus 4y cubed, or simply that will give us negative 3y cubed. And this one, 17y squared minus 6y squared is 11y squared. Then we bring down the next term. We repeat the process since this part out here, the degree is still not less than this one. So repeating the process, divide this term by this term. That will give us negative 3y right here. Yep. Then multiplying this to this one out here, and subtracting that one here, we'll obtain negative 3y times y squared is negative 3y cubed. Negative 3y times negative 2y will give us plus 6y squared, and negative 3y times 3y will give us negative 9y. Subtracting, this one would cancel out. 11y squared minus 6y squared will give us 5y squared, and negative 20y minus negative 9y, again this will look like this, negative 20y minus negative 9y. We distribute the negative operation out here, giving us negative 20y plus 9y, or simply negative 11y. And then we bring down the last term. Again, we continue the process since the degree of this one is still not less than this one. So dividing again this term by this term, that will give us plus 5, and this will, we will have here, subtract that product, the product of this and this, which is 5 times y squared is 5y squared, negative 11y times negative, 5 times negative 2y, this one, 5 times negative 2y will give us negative 10y, and 5 times 3, this one, will give us plus 50. Subtracting, 5y squared will cancel out, negative 11y minus negative 10y will give us negative y, and 16 minus 15 will give us 1. Now observe that this is already the end of our division process, since the degree of this one is already, the degree of this one is 1, while the degree of this one is 2. So it's already less than the degree of the divisor. And so the final answer for this one is, the quotient is 2y squared minus 3y plus 5 with the remainder of negative y plus 1. Or you could also write it like this one, 2y squared minus 3y plus 5 plus negative y plus 1 all over y squared minus 2y plus 3. So this idea is similar to fraction. This is like the denominator, and this is the numerator. Since we can write it like this, since this is the portion, the negative y plus 1 is the portion that we were not able to divide in this one. So let's try one last example. Let's have x cubed minus 1 divided by x minus 1. Now writing it down, you can write it as, let's use a line. Wait a second. Yep. And it's right, x minus 1 here, and x cubed minus 1 here. Now to solve this one, we might think that this is the only thing that we need, but this will actually give us an incorrect answer. So this one is wrong. The correct one is x minus 1 is divided by, we should add some, should write this one as x cubed plus 0x squared plus 0x minus 1. So we need to supply some zeros out here for variables or terms that are not present. So we write this one as x cubed plus 0x squared plus 0x minus 1. This is the correct one. So let's clear out some space. Let's fix this one. There, much better. Oops. And so, let's start the division process. First, we divide this term by the first term here. That will give us x. Multiply the product of this one and this one, and subtract it out here. Then we'll have x times x will give us x squared. X times negative 1 will give us negative x. Subtract this one, will have, oops, this is wrong. This should be x squared. Yeah, my bad. So we'll have in here x cubed minus x squared. Yep. So first x cubed minus x cubed will cancel out. It will give us 0. Or I could not put it anymore. Then 0x squared minus negative x squared will give us x squared. Continuing the process, we bring down this one. So we'll have plus 0x. And again, the degree is still not less than the divisor. So we divide this one by this one, and that will give us x. Multiply this one by this one, by this whole out here, and subtract that one and this one. So we'll have x times from this one. So we'll have x times x, that will give us x squared, and x times negative 1 will give us negative x. So subtracting this, x squared will cancel out. So that will be 0, then 0x minus negative x will give us x. Bring down the last term. We have negative 1. Dividing the first term, again, this to this, that will give us plus 1. Then multiply this to this, that will give us clearly 1 times x minus 1 is x minus 1. And subtracting this, oops, subtracting this will clearly give us 0. And so the final answer for this one is x squared plus x plus 1 as the quotient, with a remainder of 0. And so that is how we apply long division. It's actually quite a lengthy process, but if you get the hang of it, it gets easier. That is why on the next video, we'll probably discuss a special type of division called the synthetic division that is useful in dividing polynomials by a binomial. So stay in tune for that, and that's it for this video.